Thank you, everyone. Hi, welcome. I'm Kobe. I'm senior Android developer at Depop. And today I will talk about concurrent issue we have at Depop and how we solve concurrency issues. So let's first start with what is concurrency. So when we say like A and B can be concurrent, what it means? It means like they have no time dependency. What it means like it doesn't matter which one get executed first. That A and B can be executed in any random order, but the result will be always the same. And when we say A and B are concurrent, it doesn't mean like A and B are parallel. Why is that? Because concurrency itself is a concept, and parallel is more about resource, like how many resources you have. For example, your device, you only have one thread, and even A and B can be concurrent. You can only execute one task at one time, so there's no concurrent. And why we need to use concurrent and when you have a concurrent issue? Because we want to do the non-blocking programming, and for some reason, we want to avoid ANR errors. We want to provide a better user experience that whenever user interact with your app will respond. So that's why we want to do the non-blocking programming. And at Depop, we use coroutines and suspend function to achieve this goal. And if you never try the coroutine itself, give it a try. It's a lightweight thread. You can conceptually just very lightweight thread, and you will make the threading very easy. So give it a try. You will love it. So let's look at some case. So for the case one, when the user click on button and there's an analytic tracker, you need to send two tracking events. And these two tracking events, there's no dependency between them. So you just fire and forget. There's no concurrency issue you need to worry about. You just fire it. And right now, imagine you are develop some search box feature. So user type something, you make a network request to backend, and you get a result, update a view. So one possible design will be user type D, DOG, and then the user also need to tap on a confirm button or search icon, and then you make a network request, and then you get a result, update a date, update a view. In this case, you probably won't have concurrency issue because you only have one network request. But right now, you want to do something fancy. Your PM come to me like, can we do a real-time update? Like when user type D, you send a network request, and then you update the result in real time. But in the meantime, user also type DO, and you send a network request DO, user type DOG, you send a network request DOG. So the first question will be here because when you use coroutine to do the IO thread, there's no guarantee that which coroutine will be executed first. There's no specific order. So the first question we want to ask here will be, how can I make sure I can fire this network request in order? And it's a network request, right? For some mysterious reason, like the result come back in a random order, like the result of DO come back first, and then DOG, and then D. How would you like to update your view? Yeah, how do you solve this kind of concurrent issues? So at Depop, we use one feature also from Kotlin itself. It's a channel, and basically it's a queue. So yeah, it's a queue. So you will handle every event sequentially. And what it means like if you put A into the channel, you will execute A first. So you will execute the exactly order that you put this event into the channel. And so let's see how we use channel to solve this concurrency issue we have here. So I will explain this is the high level, just the concept, and we will go to code, and I will do some live demo. So let's say user tap D, and then we send it to channel. We launch a coroutine, and to send a network request, it's a suspend function. And then user right now keep typing, type DO, DOG. What happened here? Actually, these two events will wait in the buffer. It will wait until we got the result from the D, we update the view, and then we send a second request to the backend and wait for the result. In the meantime, DOG still wait in the buffer. Cool. So Right now I'm showing some code. So, wait, let me do this. So just for the demo purpose, I make it very simple so I can show you. So I didn't implement a real network request, so it's a fake one. But let's see. Let's see the first one, that you don't use channel. You just launch the coroutine. So we launch a coroutine here, and we make a network request on our thread. When we get a result, we update. So our interactor, I just mimic the behavior of the network request. So right now, if I send the order, so if I mimic that the response I get will in a reverse order that I send. So let's see, if I send the result in D, DO, DOG. So you see the result will happen in a reverse order, the D come back last. And let's see, if you use channel, how it will look like. So let's, before we do a demo, so here, the difference is that we have a channel here, and I put the string. I just put one type here, it doesn't matter. So when we bind a view, this is the architecture we have here. My colleague, Canada, will talk about architecture in the next talk, so you will get more detail about our architecture. But the thing is that when we bind a view here, we also launch a coroutine here, and we put the channel inside. So when we do this, we run the coroutine here. There's an IO thread, and this for loop itself is also a suspend function. So this thread, actually, it will suspend here because until there's an event sent to this channel. So you just wait here until that user click on button, we send an event to this channel, and then it will execute. It will fire the network request and update the view. So let's see, we didn't change anything. So the network request still will return in a reverse order. So we start D, DO, DOG. So right now, the result will be the exactly order we want, because when you fire an event, then you will suspend here. This fetch itself is a suspend function as well. So when we fire the first network request, you just suspend here, because everything inside this coroutine scope, everything will be executed in sequence. There is no concurrency in this block. So you will wait the result here, update the view, and then execute the next network request. So if I do this, that I send DO first, and then D and DOG. So you will get the DO first, D, and DOG, because it will handle the event exactly the order you send to this channel. And some of you may notice, like, we didn't solve all the problem we have, because like we mentioned before, like how we update the view. Actually, we launch a coroutine here on the UI thread to update the view. It might not happen because there's only one UI thread, but conceptually, this launch coroutine, there's no guarantee it will happen in the order you want. So how can you make it better? Here we have some pattern. We call it can build a pipeline. Sorry, let me do this first. You can build a pipeline of channel. So what's that mean? So when we do it here, the content is exactly the same. The difference is that we use this produce. What this produce function will do, actually, it will launch a coroutine as well. It will launch a coroutine here, and you have the channel inside. So the return of this function is a receive channel. So it's basically just like the producer-consumer pattern. Like producer keep producing some event, and the consumer will get the event through this receive channel. And when you get the receive channel, you just consume this event. So we launch coroutine here, and we also handle the UI straight here. So this UI also the same. We launch a coroutine here. This for loop itself is still a suspend function, so we will wait here until there's an event coming through. So let's see here. The result will exactly the same. There is no difference like between the solution we introduced before. So we still get the result in order, but the difference between this one and this one is that you can make sure that everything will happen in sequential, so you can avoid some concurrency issue you have. So right now, think about the next example, like you are doing some feature and you need to scroll and you need to do the pagination. And when you do the pagination, actually you want to handle in sequential, right? You don't want to show the second page before the first page. And when you do this kind of pagination, you might need to hold in some metadata to let the backend know, oh, I want to request the content of the second page. So for this, let's see an example here as well. So right now we just use the pipeline as the previous example. But the difference, like right now you have a metadata here. So when you get the result, I update the metadata, and then I send to the view and see what's the metadata like. So first of all, if you first page, second page, it's guaranteed like your metadata will update in order. But what's the problem with this solution? This is a problem. It's a shared mutable variable. So in the Java world, what we deal with this kind of problem, we might use synchronize method. We might use spin lock to protect this shared mutable variable. But with channel, there's something you can use to avoid issues. For example, if the new joiner and come here, you cannot avoid this kind of error, like you want to access this metadata everywhere. And right now, this metadata is shared between one I/O thread, one UI thread. So with channel, we have a skill here. We call it thread confined. All you need to do is move that variable into the coroutines. What this means? It means right now, this variable can only be accessed by this thread, and inside this scope, it becomes a local variable. So you cannot access. So for example, you cannot do this anymore because you cannot access from outside. It's a local variable. And everything inside this block will be executed in sequence, right? Because it's a channel, you make sure that everything will be handled in sequence. So you guarantee your metadata will be updated in sequence and also protect this. Not to be a shareable global variable anymore. So this is some technique you can use. Cool. That's time for the summary. So yes, there are still a lot of concurrency issues, but I cannot go through all of them today. But from our experience, actually, there's no one single perfect solution to all the concurrency issue. And yes, you just need to, it depends. It depends on your feature, your design, and your architecture. So our suggestion here is like fully understand what kind of concurrency issue you want to solve, and then just pick the right one. And the other one, so like at Depop, we also try to avoid concurrent issue by design. It's mean the very beginning. So at Depop, we start our feature by design a contract. It's a very high level, and you can see the big picture of your feature. So imagine right now you are doing a sign up screen. And when user type the username, you will check the username and send a neighbor request, check that this username is used or not. And then you need to check the password is strong enough. And then people can tap on the sign up button. So when you look at this contract, you can sense that you might have concurrency issue. I'm not saying you were 100% heavy. You can sense that there's possible. Because why? Because when you need to cache this username and password, because otherwise, when the people tap on sign up button, click, and how do you get that information? So if you change this signature to this one, like when user click on the sign up button, the view provide the username and provide a password to you. You know, before implement anything, we already know like, okay, by this contract design, we don't have to cache anything. And yeah, so that's also a very important mindset here. Is like you can avoid potential concurrent issue by design your structure in a very high level way. And it's a very important skill and very important mindset that we want to share. Oh, that's it. Thank you.